So we're not going to do a lot of these graphs, but we're going to do a couple graphs of logarithms. But let's take a look. So let's take a look at problem A. We've got log base 10 of x. So the first thing to realize is that our base is bigger than 1, which means our graph will be increasing. Okay. Also, it's not shifted left or right, so our vertical asymptote won't be going anywhere. It's just going to be where it normally would start, which is at 0. Our graph is also going to go through the automatic point at 1, 0. Okay. What's another point that it'll go through? Well, another point that it will go through is, well, think about it this way. If I have a log base 10 like I do here, what's going to make that log base 10 cancel out is another 10 basically. And we'll rewrite it as 10 to the first power so that the log base 10 and the 10 will cancel, leaving you with just the 1. What that means is you'll go through the point 10, 1. So that means over here, if I were to go all the way up past the graph, we'd go over to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go up to 1. If we continued our graph. And that also means if I had 10 to the negative 1 that I plugged in, that's the value 1/10, is I would get out just negative 1 because, again, the same would happen. The log base 10 and the 10 would cancel, leaving you with just the negative 1. So that means 1/10 spits out the value negative 1. And that's how you get that increasing graph that we normally get for our logarithms. And it will look something like that. Let's see. Looks something like that. It's not perfect, but that's it. Okay, so what's its domain? Well, it hasn't been shifted or left or right, but the graph doesn't start until 0 and continues on forever. But 0 is a vertical asymptote, so we can't include it. So it'll have a parentheses at 0. Where is my x-intercept? Meaning, where do I cross the x-axis? Well, I cross the x-axis where I normally do, here at 1. So our x-intercept is at 1, 0. Let's look at graphing another one. Let's look at y equals log base 10 of x minus 1 here in problem B. Now notice the minus 1 here is on the inside of the log. That means it's going to do what? It's going to shift us left or right. Remember, it's going to do the reverse of what you think. So if you see a minus 1, you're going to shift to the right one. The question is, how is that going to affect our graph? Well, our asymptote is normally at 0. Well, it's going to get shifted to the right one, so instead of being at 0, it's going to be at x equals 1 instead. Our point that we normally start with is normally at 1, 0. It's also going to get shifted to the right one, so it's going to be moved to, now it's going to be at 2, 0. Okay. I still want to find out what's going to happen at a couple other points so I can graph this properly. So what I'm actually going to do is I've got a log base 10. What I want is something that's going to cancel out with the log base 10, which is another 10. Well, the problem is I've got an x minus 1 in there. So the only thing that's going to get me a 10 is if I actually plug in an 11, because 11 minus 1 will give me a 10. And then what'll happen is your log base 10 and 10 will cancel out, leaving you with just the hidden 1 as your exponent. So that means when I plug in 11, so when I'm way down here at 11, I'll actually get out 1. So what it did is it shifted my point that was in my previous graph down at 10, 1, is now at over 1 at 11, 1. And my point that was at 1/10, negative 1, is now going to be at 1/110, 1, negative 1, excuse me. So it'll be in the same spot, just over 1. And so I can still draw my logarithm graph through my points. It will look exactly the same as the last problem, just the whole graph has been shifted over to the right one. Which means that is exactly what my domain is going to be, is instead of starting at 0, it's starting here at 1 to infinity. Again, there's an asymptote at 1, so I have to use parentheses. This time, instead of my x-intercept being at 1, now it's at 2, 0. Now let's look at problem C. Notice C, we don't see any parentheses, so this plus 2 that we're looking at as a part of our natural log is actually on the outside of our logarithm, so that means it's going to be shifting us up or down. In this case, because it's a plus 2, it's going to shift us up 2. So let's see what that does. Normally, our vertical asymptote starts at 0, at x equals 0. Well, shifting that up or down won't matter because it's a vertical line. It's going to stay at 0. So we'll still have a vertical asymptote here at 0. Now, however, our first point of our graph is normally at 1, 0. That will get shifted up 2. So instead of it being at 1, 0, it'll be at 1, 2. Okay, we still need another couple points to actually graph this. So what's going to be the easiest is something like plugging in E. Why? Because the E would cancel out with ln. So let's figure out what happens when we plug in E. Well, if you plug in E, we've got ln of E plus 2. Well, remember the E is to the first, so when the ln and E cancel out, we'll have 1. Plus 2 is 3. So that means E, which is about 2.7 something, when we plug it in, we get out 3. So we can plot that point. So that means when we get a little bit bigger than 2, about 2.7 that we plug in, we get out a Y value of 3. So something like this. Okay. What's another thing that we can plug in is 1 over E, or E to the negative 1. And the reason why that one will also help is because, again, if I do ln of E to the negative 1, or 1 over E, what will happen is that ln and the E will cancel out, leaving you with the negative 1. You still have that plus 2 after, so negative 1 plus 2 is going to give us a positive 1. So what that did was, by plugging in a 1 over E, which we've talked about this a couple of times, 1 over E is about 0.37. So when you plug in 0.37, you get out 1. So when I plug in 0.37, I get out 1. So it'll look something like this. And then I can draw my graph, my logarithm graph going through my points. Notice, what is my domain? It starts at 0 and goes off to infinity. Again, you have an asymptote at 0, so it needs to be parentheses. Notice I don't ask for the x-intercept because it can't be found easily. So we're just not even going to mention that. Let's look at problem D. In problem D, notice we have a -3 here. It's inside, so we're back to shifting our graph left or right. In this case, it's a -3, so we're actually going to shift it to the right 3. So our vertical asymptote, which is normally at 0, is now going to be at a positive 3. It'll be at x equals 3. Our point that we normally start out with is normally at 1, 0. Again, shifting it to the right 3, it will now be at 4, 0. Now the question is, what's happening around it again? And what we'll do now is remember, because our base is bigger than 1, this should be increasing through this point. If we need to find extra points, we could, but let's go ahead and draw our graph. We're getting the idea of what's going on here. The domain should be that our graph starts at 3 and continues on forever. So 3 to infinity, with again a parentheses, because there's a vertical asymptote at 3. We're not going to be touching that. Notice, where do I intersect the x-axis is here at 4, so our x-intercept is the point 4, 0. That can be easily found using our picture.